Hey guys, so the topic I'll be covering today is Algebra 2A, and I'm actually going over day 4. I labeled it the jumping rabbit. Here I provided a slide with the standards I will be covering in class today. And here's the objective. So I usually like having students read it in the beginning of class. For this lesson, my objective will be, given real world examples, I can write an equation, I can graph the equation, I can label and scale axes appropriately. So I usually like starting my lessons with a warm-up, and I usually give students no more than 5 minutes to work on the warm-up question. So my question for this day is convert the equation from standard form into graphing form. So for this example, I actually put vertex form in parentheses. The reason why is because I tend to use them interchangeably during class, and students already should know that I mean the same thing. So the problem I gave them is y is equal to m squared plus 6m plus 9. So what students should already be familiar with is the fact that students should know what the standard form is for that equation. So specifically for this example, we would have a as 1 here, b as 6, and c as 9. So in order for students to start converting this equation into the graphing form, they should know that they have to take the c value, add it to the left side, take the b value, divide it by 2, and square it. And that's a value that they're going to add on both sides. Final step, move it over to the other side. And of course, that's something that I go over in class with them. And if they have any questions or concerns, I make sure to answer their questions during my guided example. So another question that I provided for them here is, using the equation above, determine the vertex. So this should take no more than 1 minute as soon as students are finished converting this into graphing form. And again, I usually go over the warm-up right after they finish. Alright, so for the lesson, I titled this, How Can I Model the Data? So I'm providing students with a guided example. This guided example is on jumping rabbits. So let me actually read it. It says the diagram at the right shows a jackrabbit jumping over a 3-foot high fence. To just clear the fence, a rabbit must start its jump at a point 4 feet from the fence. So for this activity, I'm expecting students to break up into small groups of 3 or 4 students. The purpose of this is for students to analyze the jumping rabbits and to create a starting point that works for this real world example. I actually provided students with discussion points. Let me actually go over them. The first one is, how can we make a graph fit this situation? What information do we need in order to find an equation? And how can we be sure that our equation fits the situation? And I'm actually having students use decimals for this example. Let me actually go to this. And it's actually pretty neat because students actually get to move this jumping rabbit around. So the purpose of them is for, so when students are placed in groups, they should be discussing, so what would be a valid starting point for this jackrabbit? So what I want them to understand is that the jackrabbit would never start at a negative x value, because that would kind of be similar to the jackrabbit jumping from underneath. So yeah, those are just kind of discussion points that I'm expecting during group discussion. And I usually walk around, make sure that students are staying on task, and if they need any clarification, I make sure I give it to them as I walk around the class. So yeah, and it's also really cool because decimals actually provide students with the A and the B values, so that's pretty cool, I think. All right, so in their groups, they have to answer the following questions. So the first question they have to answer is what is the shape of the path of the jackrabbit? What kind of equation would best fit this situation? So based on the previous lessons, students should already understand that for quadratic formula, they should usually end up with the form of a parabola. The next question is, what point on your graph can tell you about the values of h and k in the equation? Write the values for h and k into the general equation. Is your equation finished? So again, this ties into the warm-up. So students are making connections of h and k, which in this case represent the vertex. They have to plug it back into the equation, which I'm expecting the vertex form or the graphing form of the equation. And for the last question is, with your team, find the strategy to find the exact value of a. Will any of the points on your diagram help? So again, students should already be familiar with all these parameters. They were covered during the first day of the lesson. And that's it. Thank you.